Hello, everyone. We're back again. So this would be part two of our two-part series on how psychologists do research. So today we're going to focus a little bit more uh, on statistics, and we're going to go beyond our discussion last week where we were talking about this idea of hypotheses and hypotheses coming from theories. Now you derive your hypotheses in such a way to answer a question that is falsifiable and that can be replicated. So this is a natural follow-up to that. So if you haven't already, then go ahead and start chapter 2 in your book and try to finish it if you can. And then we've got some other things planned, hopefully going up on the website this week. All right, so how psychologists do research, part 2, statistics. So first and foremost, they utilize a plethora of different statistical ways to get at answering certain questions. You'll get a lot of these and more in your methods and statistics course. But for today, we're going to just briefly go over what some of these things are, right? So the first thing we're going to talk about is correlations, right? And correlations are simply a way to understand if two events have any type of statistical relationship to one another, right? So correlation is the measure of the strength of a positive or a negative relationship or associationship between two different variables. Correlations are measured between -1 and +1. Now, -1 would mean there's a negative relationship. That means an inverse relationship between two variables. And +1 means that there is a positive relationship. So a clear associationship between two variables. Because it's a range, you can also have a correlation coefficient of 0, right? And the correlation coefficient is simply the measure of the strength of the correlation. A correlation coefficient of 0 means that there's no relationship whatsoever between these two variables, right? So either there's a negative relationship. So, and remember, these things are on a range too, right? So a negative relationship would be anything that goes from like -0.1 to -0.1 to -1. And a positive relationship would be anything that goes from +0.1 up to +1. If you have a relationship of 0, then there is no relationship whatsoever. Now, I can demonstrate this for you sort of in these sort of graphical representations. And again, this is very generalized. You will get into much more understanding of this in your next few classes. But for now, when we talk about a positive correlation, right? We're talking about as one variable goes up, the other variable also goes up. Variable A goes up, variable B goes up, right? So we might say scores on a psychology exam and then the number of kumquats eaten, right? And so the more kumquats that you eat, the higher your score will be on your psychology exam. So that's a positive correlation. As one goes up, the other goes up. As you can see, it'll be in a diagonal form. And the further you get on your x-axis, the higher that score becomes, the higher you also get on your y-axis. So the more kumquats you eat, the higher your score would be expected to be, the higher your score is on a psychology exam. So if you ever take a psychology exam for me, be sure that you load up on kumquats first, right? Now, when we look at this negative correlation, we see the exact opposite, right? So the number of kumquats eaten increases, but when we look at our y-axis, the number or the score of the psychology exams goes down, right? So 25 kumquats eaten, right? You get a score of 3 for this example, right? So as one variable goes up, the other variable goes down. Okay. So if we were to get this data, then that means that if you get a psych exam from me, you should not eat kumquats, because the more kumquats you eat, the lower your grade's going to be. Okay. Now, zero correlation, right? So you have a correlation coefficient of 0. That means it doesn't matter. These two have no relationship. A 0 correlation coefficient means no relationship between the two variables. It doesn't matter the number of kumquats you eat. No matter the number of kumquats you eat has no bearing on your y-axis, has no bearing on the scores that you will have on your psych exam. So it doesn't matter if you eat kumquats or not when you're taking an exam with me. All right. So positive, as one goes up, the other goes up. Negative, as one goes up, the other goes down. 0, no relationship. That's all you need to know about correlations right now. Now, as far as cautions though, correlations are a beginning step. They don't tell you the full story. Oftentimes when you see correlations mentioned in the media, they're based on rumor and anecdote, and they're not supported by actual data, right? A lot of times correlations are illusory. In other words, we think two things are related and they absolutely are not, right? So sometimes they're false correlations in the sense that we believe very strongly that two different variables should relate to one another, and yet they don't, right? Like eye color and height, right? Seems like that might be a relationship together, but there isn't. Now, illusory correlations create dangerous beliefs, right? So, for example, and also cause great social harm. For example, right, there is this huge conspiracy, right, that there's an association between autism and vaccinations for childhood diseases, right? So because of that, many parents have stopped giving vaccines to their children. And what we're seeing as a whole is diseases that we have pretty much eliminated are now coming back into society because of parents' refusal to take these vaccines because they think that these vaccines will cause autism, right? So there's that. Second thing is just because so look, this might sound confusing, but stay with me here. Just because these two variables might be related, right? So just because kumquats eaten is related to the score that you receive on a psych exam, it doesn't mean that the relationship is causal. It just really means that they are associated together, right? A causal relationship means that one variable caused the other variable, right? So there's nothing here that says eating boiled kumquats, right, causes you to get a higher score on your psych exam. All this is saying is that there is some type of relationship between the number of boiled kumquats that you're eating and the scores that you get on your psych exam. Now, perhaps there is some variable that this is working through. Perhaps there's some unknown force that's manipulating both of these variables. Something could be happening to cause this relationship, just like in this grid here. Something could be happening to where there's no relationship between the two variables in the zero correlation, right? And so a golden rule that you will hear over and over and over again in your classes, right? A correlation between two variables does not demonstrate a causal relationship. In short, correlation does not equal causation. Correlation does not equal causation. You will hear that over and over and over and over and over again. Because otherwise, you can make the mistake, right, of thinking a variable causes another variable. And then this can cause an ill for the entire society, but also it will ruin your study. So let's take a look at this, right? So the number of people who drowned by falling in a swimming pool versus the number of films that Nick Cage appeared in, right? So it seems to be the case that there's a correlation of about 0.6. To give you a sense, 0.6 is a fairly moderate, going towards strong correlation. Now remember, 1 means that it's a strong, perfect correlation, right? 0.6 correlation means that for some reason, when Nick Cage appears in a lot of movies, more people drown. Okay? So now, is Nicolas Cage appearing in movies causing the drowning? Well, no, that's silly, right? But there is some association between those two variables. But we can't say that Nicolas Cage appearing in movies is causing it, right? And so we just need to sort of think this through and figure out what could be accounting for the number of drownings that we're seeing versus Nick Cage appearing in movies. It turns out there's actually a fairly decent explanation for that. Can anybody guess what it is, just for looking at this? I'll give you another second. So, as it turns out, Nicolas Cage movies get released in the summertime. What are people doing in the summertime? They go into swimming pools. If you have a large amount of people going to swimming pools in the summertime, you have a higher risk of more people drowning in those swimming pools in the summertime. So as you can see, there's a strong associationship, but it's not causal. Nicolas Cage has done a lot of amazing things, a lot of terrible things, but it ain't the cause of people drowning in summertime. So you've seen correlations. Correlations can give us an idea of where to look and how to look and where to start our research, right? They tell us something about these two variables. A tool that you'll really use, though, is experiments. Experiments really allow us to see how variables operate in the real world as a function of manipulations that we do in the laboratory. They give us a strong idea of where to go and where to look and what we're going to see. So experiments allow researchers to control the situation being studied, to manipulate an independent variable, and to assess the effects of a manipulation on the dependent variable. Ideally, everything in the experimental situation except the independent variable is held constant. So you keep it the same for all participants. And when you keep it the same for all participants, you're minimizing the ways that individual differences could impact the variables that you're trying to test. So remember, you're going to manipulate an independent variable. And in doing so, you're going to see how that manipulation impacts the dependent variable. What changes will you see in the dependent variable as a result of the manipulations you did in your independent variable? So let's go through this. Let's say we want to look at the use of cell phones and its impact on driving ability, right? So our independent variable might be the use of cell phones, right? So we have two groups. We have our experimental group, we have our control group. The experimental group gets the treatment, right? So in the experimental group, we allow them to talk on their cell phones while they're in the driving simulator. But the control group does not get the manipulation. So the control group just sits in the simulator. It doesn't talk on the phone at all. Do you see that? One group talks on the phone, the other group doesn't talk at all. And then we look to see what is the number of collisions that take place as a result of that. And the dependent variable, right, we look at the number of collisions that are a result of people in the simulator talking on their cell phones. Now, is there a difference in the number in between those who were talking on the cell phones and those who weren't? Is that difference statistically significant? And was there a large effect size? Now, remember we spoke a little bit earlier about probabilities, right? This p-value, so to speak of, and what's the probability that your findings are actually significant. So when you start doing experiments on your own, you're going to report your p-value, and you're probably going to report your effect size. For now, all you need to know is one of the things that we want to report is this measurement of what is the number of collisions for an experimental group, what is the number of collisions for a control group, and is the difference between these two statistically significant? Okay, is it statistically significant? So experimental groups and control groups, now you know, control group is the one that doesn't get your manipulation, but your experimental group is the one that does get your manipulation. Now, sometimes a control group is given what's called a placebo. Right? A placebo, I know it's a funny sounding word, right? But a placebo is simply a treatment that is made to resemble the real treatment. So, but it's fake. So for example, I might want to administer pills to someone to see what effects those pills have, right? However, in my placebo group, I administer pills that look like those pills, but actually those pills are sugar pills. So they're not real pills. If the placebo produces the same result as the real thing, then what we know is that the reason that the participants experienced a change was due to something about their expectations and not their own, and not the treatment itself. This is what's called a placebo effect. The placebo effect is simply, I'm in the experiment, I believe I got the treatment, I didn't get the treatment, but I still experienced a change. So the change is not due to the treatment. The change is due to my expectations about the treatment. Placebos are absolutely necessary if we want to test new drugs that are coming into the market. Okay, they've been using placebos as a way to test the efficacy of new drugs for treatment of depression, anxiety, other types of illnesses, because we need to know to what level a person's expectations are actually causing the change and the healing versus the drug itself. So, does Viagra work for women, right? So here, the percent reporting improvement in their sexual responsivity, right, for women is at about 40%, but in the placebo group, so this group received a blue diamond-shaped pill that resembles the regular blue diamond-shaped pill, right? It looks like Viagra, except this blue diamond-shaped pill that the placebo group received is just a sugar pill. But they actually experienced greater change than the group that received the actual treatment. What does that tell us? It tells us that expectations of treatment matter a lot in healing. And if you ever take health psychology with me, we'll talk about this a lot. But sometimes your expectation to be healed is what results in the actual healing or the actual parts of treatment that are taking place. All right, so single blind and double blind procedures can be used to prevent the results from being affected by the expectations of the participants and expectations of the experimenter. Remember, we spoke a little bit at length. It doesn't make sense, a little bit at length. We spoke a little bit about bias last week, right? And so single blind, so the participants don't know what treatment they're getting. And double blind, which is one of the gold standards, is that the participants nor the experimenter know what treatments the participant is getting. This way, you minimize bias and you can only focus on what the findings actually are. Remember, confirmation bias, right? So you don't want to confirm things that you're expecting to happen. And so this right here helps to minimize that because you don't know what they got and they don't know what they got either. Okay. So there are different types of statistics that as a psychologist we will use in order to assess, understand, and analyze our research findings, right? So psychologists will use descriptive statistics to summarize that, data, okay? So that's the mean and standard deviation. The mean tells us what the average response is, right? And then standard deviation tells us what is the spread. So of those responses, of the data that we got, what is the spread of the answers? What are the ranges from the mean to where the responses actually fall for that subject pool? Also the mode, so the number that's used the most, that's seen the most often, as well as the median, where exactly 50% of the participants lie. And these together work to give us the big picture. But of these statistics, only the mean is something that we can actually manipulate. The mode and the median do not lend themselves to statistical manipulation. So when we talk about standard deviation, we're sort of talking about this curve here, right? So we're really talking about when we take on average, right, the spread of all the numbers, this 0 right here represents what the actual mean is, right? Now, if this is the mean, right, then where do 68% of the scores fall? 34% of those scores are one standard deviation away, meaning 34% of those scores are above the mean, and then 34% of those scores are below it, positive and negative, right? So even though this is a 0 here, imagine this as your actual mean, right? Each standard deviation away tells us how close to the mean is the average of the answers that are in the data that we're getting. How close to the mean is the average of scores that we're getting? And we know the average of the data is the actual mean, but how close are the actual numbers, the actual scores that we're getting in the data? Right? 34% of those scores give us one standard deviation away, right? And then 68% of those scores give us the full positive and negative standard deviation away. Okay, so that tells us information between one standard deviation. Typically 98% of the scores should fall within 3 standard deviations of the mean, right? So how close, how much does the score deviate between what we're actually seeing, what we actually have? All right. So psychological statistics use inferential statistics to draw inferences about how meaningful the findings actually are, right? So descriptive statistics tell us and they describe. Inferential statistics help us to predict. So significance tests tell us the researchers how likely it is that the results of a study occurred merely by chance. So something you'll see a lot is this idea of P values, right? P means probability value, okay? Essentially, you want your P value to be less than 0.05. Essentially what you want is to say, there's less than a 5% chance that the findings I had occurred purely to chance. There's a 95% chance that my findings occurred due to the manipulations that took place in our study. Right? Your results are statistically significant if the likelihood that they occurred purely by chance is less than 5%. Sometimes you might want to be stringent and it might be less than 1%, okay? Confidence intervals are the range of values that can be 95% certain contains the true population's mean, right? So this is a confidence interval, right? So study 1, study 2, study 3, study 4, right? All we're saying is when we repeat these studies, this line gives us a representation of how likely it is that the true mean of the true population, right, is somewhere in this range. So in study 1, this was our average, but the real mean of the actual population is somewhere in this range. In study 2, this was our mean, but in the population, the real mean is somewhere probably between this range, right? In this study right here, something happened. If we look at this, we can clearly see something happen. Something happened again in this study as well. So for this study, even though our mean is here, the population is over there and the population is here. So means then give us an idea of where to look. And our confidence interval tells us where 95% of these scores probably are in the actual real population. We say real population because I can't bring in everybody on Earth and bring them into my lab. So the last step in any study is to interpret and figure out what your study actually means, right? So you've got to choose between competing interpretations, and you have to make sure that you don't go beyond what the numbers tell you. Numbers will give you a set of observations. You cannot go beyond those to make other ideas as to what your study means. You must stick to the data. So remember, sometimes the best interpretation does not emerge until a hypothesis has been tested in more than one way. So even though you have an hypothesis and you found results that either confirm or disconfirm the hypothesis, you might still need to test the hypothesis multiple times, right? Testing, remember, do you remember cross-sectional methods? What's that? Look back if you don't remember. And do you remember what longitudinal methods are? Look back if you don't remember. But you can test using these ways. And these are ways of doing a study you can test over time, right? Sort of figure out where your differences may statistically lie. Now, many journals require the use of alternate methods and statistics, and then the effect size is something that you will probably be reporting. Now, I'm introducing you to an effect size early on, because back in my day, which was a long time ago, we didn't really talk about effect size in undergrad until you get to grad school. But I'm going to do things a little bit differently, because what will happen is you'll go to grad school and your advisor will ask you what your effect size is, and you will have no idea what she's talking about, and it's very uncomfortable. So effect size are simply the objective, standardized way of describing the strength of the independent variables influence on the dependent variable. What size is the effect of the independent variable on the dependent variable, right? So don't get all these terms mixed up right now. We're going to go through them multiple times, right? But for now, right, your p-value, so what's the probability that the findings I have are due to chance? I want the p-value to be less than 0.05. So I want the p-value to be 5% that it's due to chance. And then effect size is what is the strength of the relationship between my independent variable and my dependent variable? How strong of a change and an effect that I see in my dependent variable as a result of the changes I implemented in my dependent variable. Now, another statistical tool, meta-analysis. Meta-analysis takes data from different studies that are related, right? So you might look at safe sex practices over different decades, right? And you might be trying to chart the most effective means of practicing safe sex. So because you're tracking different studies over different decades, this meta-analysis is like an analysis of all these analyses, right? So it's your meta-analysis, and it combines these data, and then it looks for trends, and it looks for things that support a major theory. It's very rare that one study finds one thing, right? So if you analyze all these different studies, right, then it really adds some strength and robustness to whatever your findings are. People who can do meta-analytic data analysis get paid a lot of money. That's very difficult to do. So if you're someone who comes along later in psychology and realizes you like statistics, doing a meta-analytic study is one way to really get your name out there. Now, you need to be suspicious. We talked about having a healthy level of skepticism. So you need to be suspicious of headlines that announce a major scientific breakthrough based on a single study, right? A major scientific breakthrough based on some single study. So just be careful when it comes to that. So that's all the statistics stuff we need to know for now. Now I need to talk about actual ethics, right? There's actual ethics that go into place with doing research with human beings. So participants who enter your study have to do so voluntarily and have to know enough about it to make an intelligent decision on if they want to do the study or not. This is called informed consent. This is where they find out things about what's going on in the study. They get a general sense of what you're testing. You won't tell them exactly, but they get a general sense of what you're testing, and they get to make a decision on their own as to if they want to take part in it, right? APA, so the American Psychological Association's ethical code, requires us to give informed consent to those who are participating in a study. And if you're doing a study with children under the age of 18, you have to give what's called informed assent. So they know what's going on with the study, and so do their parents. This is to protect everybody in the study from harm and to keep risk as minimized as possible. Right? You also must do debriefing. So when a study is over, you must discuss with the participants what you were testing, why you were testing, why you asked the questions you did, and what was going on. If you use deception, now sometimes in psychological studies, you do a study that requires deception. Essentially, you're lying to the participant for some reason. APA has very strict standards about that. So if you're going to lie to a participant, APA wants to know why it's necessary for your study. And then when the study is over, you have to debrief your participants and tell them what the lie was and why you lied. So, and that is weighed up against the potential values as well as the alternative procedures that you could have used that weren't going to work. If you had to lie, then there must be some reason why lying was what you had to do. And if you have to be able to discuss that when you are creating your study. Finally, I don't know how people in the class feel about this, But psychologists study animals to gain knowledge about particular species, as well as to study similarities between those animals and human beings, right? To clarify theoretical questions, and then to study issues that can't be studied with human beings for practical or ethical reasons, right? We do a lot of animal testing because you can't do the same testing on humans. Now, inherent to that is a statement that human life is more valuable than animal life, right? And so inherent to that is a thought that the reason you have to study human beings or study animals is because they provide you some knowledge or insight that you would not normally get by studying human beings, right? So, and also we're using animals in a way to improve human welfare, right? So, and so that's just that topic there. There's a whole lot of ethical issues that we could get into about that. If there's someone who really values animal rights, there's a whole argument against doing that, right? So I'm just going to leave that there, but just know that there is some value and some benefit to studying animals in a way that it oftentimes points us in the right direction for things that we need to understand about the human condition. I'll just leave it there. Many regulations govern how animals are treated and how they're utilized in research, as well as to trying to provide the proper care and, in many cases, the proper disposal. And that is all for today. Now, we have covered a lot, so please read your books. I'm going to upload some stuff to the module this week that will help you out in understanding some of the things we spoke about. Again, these are very topical, so we're going through them very fast. Each of these topics could be their own class, and many of these are. For now, all you need to know is the stuff that I covered in the slides. So have another great week. Please keep safe. Remember to keep masking up, and I will talk to you later.